continue with a little bit more work. Complex numbers in rectangular form. Remember the pattern of j to the second, j to the third, and j to the fourth. J is just the square root of a negative 1, but let's just think of it as j. J squared is a negative 1. J cubed is a negative j. And j to the fourth is back to 1. So if I came over here, I'd keep repeating this. So j to the fifth is the same as j. J to the sixth is the same as j squared, which is a negative 1. J to the seventh is the same as j cubed, which is a negative j. And j to the eighth is the same thing as j to the fourth. Here's why, and this is true for all of them. J to the eighth is j to the fourth times j to the fourth, which is 1 times 1, which is 1. So j to the third right here is a negative j. So I have 2 minus a negative j, which is 2 plus j. And I'll raise it to the fourth power in a minute. Downstairs, j to the eighth is just 1, and j to the sixth is j to the second, which is a negative 1. So I'm going to erase that now with a negative 1. And all of that's got to be cubed. Of course, I'm going to add j at the end. This is 1 plus 1 for the denominator. And 1 plus 1 is 2. And 2 cubed will be 8. Let's go to the upstairs. So this is 2 minus j. 2 minus a negative j, which is 2 plus j. And I have to raise that to the fourth power. Don't forget, downstairs, I have 2 to the third, which is 8. I'll put way over here plus j. 2 plus j to the fourth power, I'm going to do this. I'm going to write it out as 2 plus j times 2 plus j times 2 plus j. I'm going to get rid of this right here for now. Times 2 plus j. There's 2 plus j to the fourth. I'll try to write that plus j way off to the end. Again, all over 8. I'm going to have you recognize that when I FOIL that, whatever that answer is, will be the same as this. So 2 times 2 is 4, and then I'll get a 2j and a 2j in the middle, which is a total of 4j, and j times j is j squared. J squared is a negative 1, so 4 minus 1 is 3 plus 4j, and that's what this would be as well. So now I'm going to FOIL that, and then put it over top of the 8. So let's do this first. So 3 times 3 is 9. 3 times 4j is 12j, but here's another 12j for a total of 24j, and 4j times 4j is 16j squared, which means, don't forget, a minus 16. So 9 minus 16 is a negative 7 plus that 24j, all divided by 8, finally. And then I have this j over here at the very end. I think what I'll do, oh, I see what I'm going to do. I'm going to put the negative 7 over top of an 8, but then this 24j over 8 would be 3j, and I add to that 1j, and I'll have 4j. And you know, I don't know how the book wrote this, but I'm going to leave it like this. I could even write this as a decimal number, 0.875 plus 4j. I'm all done. I've done all of the raising to the fourth power, cubing, simplifying. What a lot of work to get down to that answer. Let's look at another problem. I had it written out, so let's see, where did it go? I think it's, yeah, that must be it. Write the reciprocal of 3 minus j in rectangular form. It's question number 49. Well, the reciprocal of something is 1 divided by it. So 1 over 3j, 3 minus j. So I'm going to multiply by the conjugate, which is 3 plus j, top and bottom, because I'm multiplying by 1 when I do that. But downstairs, when I FOIL that, this 3 times 3 is 9, and this minus j times a positive j is a minus j squared. Don't forget, that's 9 minus a negative 1, or 10. Upstairs, I have 1 times the 3 plus j, and, you know, I think that's it. Write the reciprocal of 3 minus j in rectangular form. Again, might write it as 1 over 10 times 3 plus j. Might write it as 3/10 plus 1j over 10 is another way to write it. Let's go ahead and do another one. So let's take a look at number 51. It says to write j to the negative 2 plus j to the negative 3 in rectangular form. So remember, a negative exponent should be rewritten as 1 over that variable to a positive power. And j to the negative third is 1 over j to the third. J squared is a negative 1. So this first fraction is 1 divided by a negative 1, which is just the number negative 1. The second fraction, j cubed, is a negative j. So I'm going to multiply it by its conjugate, which is a positive j. And so I will have, oops, I shouldn't have changed that. That's a plus sign. Upstairs in the numerator, I'll have 1j. And downstairs, I'll have a negative j squared. Remember, j squared is a negative 1, so a negative 1 is a positive 1. So what I have now is that negative 1 in front plus j over 1, but I don't need to put that 1 there, and I'm just going to erase that, and I'm just going to call this a negative 1 plus j. All done. I'm going to sneak one more in. It's question number 59. It says, if the voltage E is given in a circuit, it's represented by 85 plus 74J. And the impedance Z is given in the circuit, and it's represented by 2500 minus 1200J. Find the representation for the current. So they want us to find I. Oops, that's supposed to be a question mark. So I'm looking to find I. Oh, my word. Concentrate. There we go. I was trying to think of the formula, and so that's why I wasn't concentrating. Voltage equals I times R, but impedance is similar to resistance. Remember, its units were in ohms. So the formula E equals I times Z is the one that we need to use, and we would have had to refer to an example in the book that talked about that. But if I want to find I, I'm going to divide both sides by Z in order to get I alone. So what I need to do in this problem to find I is to take the voltage of 85 plus 74J volts and divide it by the impedance of 2500 minus 1200J ohms. But in doing that, I'm going to multiply by the conjugate of the denominator, so that would be 2500 plus the 1200J. And I'm going to have to get my calculator out to do this. These numbers are a little large. But let's go ahead, and I've got it here, so I think I'll just go ahead and keep rolling. So the 2500 times 2500 is 625 with 4 zeros. Don't need to type that one. 2500 times 1200, and then the 2500 times 1200 disappears. And this minus 1200 times the positive 1200 is a minus 144 with 4 zeros. And that's a j squared. So the denominator here will be a 6,250,000 plus 1,440,000, and I'm just going to go and get that. So that denominator is going to be 7690, comma 000, 7,690,000. Remember, because this was a minus something j squared, it'll be a plus that value. Let's see. I'm going to go ahead and scroll here. So I've got to now take 85 times 2500, and I get 212500. Just be careful. 85 times 1200 is, and it's a j term, it's 102000 with j. Now I have 74 times 2500, and it's also a j term, 185000J. And then finally 74 times 1200, and that's a j times j, so that's a j squared, and it's a positive 888 Remember, it's J squared. So that will become a minus 88800 to add to this. So I'm going to do that real quick. And I believe when I take this number and subtract that number, I get 123,700. That's the real number part. Now I've got to add those two together. I hope I have the right number of zeros there. And it looks like it's 287,000 J. Remember, all of that is divided by this 7,690,000. I think I said that correctly. And then, you know, my guess is the author is going to take this number divided by this number. So 123,700 divided by the 7,690,000. And the decimal equivalent for that is 0.0161. And then this 287,000 divided by that. And that's going to be 0.0373 J. This is the current, so that's going to be in amperes because I believe I had voltage and resistance for those. It doesn't really say that I should write that. Hopefully no multiplication errors. The gist is correct, that's for sure. So some complicated problems from Chapter 12, Section 2.